Welcome back, pals. Today, we're going to be learning about uneven heating and pressure systems around the globe. So you've got a good understanding of greenhouse effect, and you've got a good understanding about where that heat comes from, where that heat's going. Now we're going to look at how that heat is impacting our globe. So make sure you put your page number. I'm not quite sure what page number we're going to be on when I'm recording this, so just make sure you have the correct page number up here. The title of this page is Uneven Heating and Pressure Systems. Uneven heating and pressure systems. All right, we're going to take this paper and we're going to put it on its side. Okay. Now, on this part of the paper, I'm going to zoom you out just a little bit. Okay. On this side, on the left side, we're going to look at, we're going to draw a globe. And then on this side, we're going to draw a pressure system. And we're going to try and kind of explain how global distributions of uneven heating and pressure systems go together. So let's make it happen. When we draw this globe, we're going to kind of go out just a little bit, kind of like this. So something like that. It's not going to be perfect. It's totally fine if it's not. Okay. This center of the globe is called the equator. I'm going to write that on this side. EQU. Sorry, I got a little excited with my U and my A. I don't know what I thought. Okay, equator. Now, when we're going to start talking about how the greenhouse effect impacts the heating, there's a couple things we need to know about the globe. First is we have the equator. It is that 0 degrees line. It separates the globe into the northern hemisphere and the southern hemisphere. Okay, so everything up is north, everything down is south. There are 3 other latitudes. Because remember, latitudes are the lines that run side by side. So we're going to need to know this one, and then up at the top. So this is 30 degrees. This is 60 degrees. And this up here at the pole is 90 degrees. Same thing for the southern hemisphere. We have 30 degrees, 60 degrees, and then 90 degrees at the pole. Okay, those are the latitudes. They are what they are. 30, 60, 90. 0, 30, 60, 90. 30, 60, 90, 3, 6, 9. 30, 60, 90. Those are the latitudes that you are going to need to know in your brain. All right, now, we know that the sun is shining on Earth, and it shines directly at the equator. Therefore, we know that the equator is the hottest area on this globe. Yes? The poles, it's indirect heat. So this is the coldest area on the globe. We're going to draw that kind of up here in the little margin area. Okay? So we're going to have uneven heating. Here's our whole globe. Here's the equator. Okay, I'm just going to put the E for equator. Here's the sun. Okay, sunlight. Sun is coming in. This sun is directly hitting the equator. This is direct sunlight. So if I were to draw a line on the equator, it would be close to not like a direct hit. See how this area is curving? This is indirect, and then even more so. See how this curve is curving? So this light, the angle, let me zoom you in so you can kind of see better. This is directly hitting, it's almost a 90-degree angle. This is having to curve over a wider area, and then up at the poles, it's really spreading out. This is direct sunlight, and this is indirect sunlight. Okay, direct sunlight and indirect sunlight. That direct sunlight is going to be hot. This indirect sunlight is going to be cold. Okay, hot at the tropics, at the equator, cold at the pole. Cold pole, hot tropics. Tropics, hot. Cold poles at the poles, North and South Pole. Good to go so far. Fantastic. Now, the next thing that we're going to review is convection. So this is the uneven heating. Here is convection. So we have rising. This is our warm rising air. Then we have our cooling arrow. Okay, so we have hot air rising. That hot air, once it's risen, must start to cool. That cooler air then sinks. So this is sinking. And then our arrow down here is warming. Warming, rising, cooling, sinking. Convection, uneven heating. Direct hot, indirect cold, warming, rising, cooling, sinking. Okay? So, let's apply convection to the globe. Here's our globe. Equator. We know the equator is real hot because it gets direct sunlight. Hot. Hot air is going to rise. So at the equator, and you might want to grab, go ahead, pause this video if you need to, and grab a red and a blue color. Okay. All right. At the 0 degree, hot air rises. Because remember, air, all this is air. This is the surface of Earth, and this is the atmosphere. Okay? So hot air rises. That rising air is going to get trapped by the ozone layer. We know that the ozone layer is somewhere, I don't know, let's just, cool. It's going to get trapped. Heat gets trapped by the ozone layer in the stratosphere. So it's going to get trapped in here. Rising, cooling. Here is our sinking arrow, and it happens every 30 degrees of latitude. So I'm gonna just throw some blue on the cooling. And then here, that air is not gonna go into the earth. The earth is not gonna just absorb the air. The air is gonna hit the earth and it's gonna go whoosh across the surface. So here's our warming arrow. Warming, rising, cooling, sinking. Now, this is a pressure belt. A pressure belt of circulation of air. Now, it's separated by hemispheres. So this is in the northern hemisphere. What happens in the northern hemisphere is also going to happen in the southern hemisphere. So we have warm air rising. It's going to cool. It's going to sink right at that 30-degree line. And then it warms and replaces. So warm air rising, cooling, sinking. Warming, rising, cooling, sinking. Good to go so far? Okay. This in the middle right here, this little spot, when we get to global winds, this is a specific area. These are the winds that are called the doldrums. But that's in the next unit. We're just worried about convection cells, circulation patterns, and pressure systems today. All right, now, I think the easiest way to do pressure systems is to do the areas that you know. We know uneven solar heating. We know that there's direct sunlight at the equator. We know that there's indirect sunlight at the poles. So we know it's gonna rise at the equator and it's gonna sink at the poles. Cold air sinks. That cold air is gonna hit Earth's surface. It's gonna whoosh and move across Earth's surface, and then as it whooshes, it warms, and it's gonna rise at the 60, okay? This changes every 30 degrees of latitude. As it warms, I'm not gonna say this is warm air, I'm just saying it's warmer than this air. This air is cold, this air is warmer. Warmer air is gonna lift up. It's going to get trapped by that ozone layer. Heat gets trapped. And then it's going to cool. Sinking, warming, rising, cooling. Okay. What happens in the north also has to happen in the south. So we have our 90 degrees, sinking. We know that it's cold. Uneven solar heating. That's how we know that the poles are cold. It's gonna sink, hit Earth's surface. It's gonna whoosh across Earth's surface. There's that warming arrow because air is not gonna go into a solid. If I blow on this table, that air is not gonna go into the table. It's gonna move across the table so it hit the notebook paper. All right, so there's warming, and then it's gonna rise at that 60. So it's now all warm. It's warm enough that it's gonna start rising. That rising air is gonna cool and then sink again. Okay? So we have so far our tropical pressure systems. We have our polar pressure systems. Now we're gonna need our moderate pressure systems, or temperate. Temperate's the word I was looking for. Okay, now these arrows, if you haven't noticed, they're besties. They occur together in pairs. So this is going up, its buddy is gonna go up. If this is gonna be sinking, it's gonna pull the air next to it down, okay? Air and water want the path of least resistance. So since this air is already sinking, this air next to it is just gonna get caught in the flow. We're just gonna get caught in the sauce. Okay, so we have sinking air. It's going to whoosh across the surface. Okay, so if you think about like a water hose, if I had a water hose hit the surface, it's gonna hit the surface and it's gonna fan out, right? Hit the surface and go whoosh across the surface. Just like if you had a water fountain going upwards, it would go up and out just like that. Okay, same thing here. It's gonna go down, hit the surface, and just shoo across the surface. Warming. Oh, look at that, the pattern continues. We have a rising arrow right here. The air next to it is also gonna rise. Okay, so there's your convection cell there. Rising, cooling, sinking, warming. All right, what happens in the north also has to happen in the southern hemisphere. So we have cooling air, sinking air. We have sinking air and sinking air next to it, rising air, and it's gonna pull the air up next to it, and then it's gonna complete that cycle. Okay? Crashing, lifting, warming, lifting, cooling. It's separate ways. Okay. All right, so those are our major pressure belts. These pressure belts are spread throughout the globe, and that is how air circulates. Remember, because this is land, this is the earth, this is the atmosphere, and this is how that air circulates in our atmosphere. And it's driven by uneven solar heating. Oh, we should write that. Uneven solar heating, uneven solar heating. Uneven because it's direct at the equator, indirect at the poles. All right, now let's put all this together and let's go through pressure systems. So these are called pressure belts, and a pressure system happens when you have two of these arrows coupled together. So we have a high pressure system and we have a low pressure system. High pressure, go ahead and start putting some blue there, and we're gonna have a low pressure. This is gonna come back around when we get to weather. All right, so for high pressure, and then low pressure. And then remember, air pressure. When we talked about air pressure in the atmosphere, pressure was just about pressing. Look, the air is pressing down on Earth's surface. This air is lifting off of Earth's surface. That's going to determine its pressure system. Pressure, pressing. We have atmospheric pressure always, but that atmospheric pressure and the uneven solar heating, hot at the equator, cold at the poles, it's going to create another set of pressure systems. Okay? All right, high pressure. High pressure means that it is pushing against the ground. Pushing on ground. Low pressure is lifting off ground. Lifting off ground. Sorry, let me zoom you in so you see it a little better. Okay, high pressure is happy, clear, and dry. Happy, clear, and dry. And these are all weather words. Low pressure is lousy, humid, and rainy. My keyword here, high is dry, which rhymes with high. High, dry. High is dry. Okay, and for low pressure, low is wet air. Just air with water. Dry air, air that has a high humid content. Low pressure has more water available to it. That's what humidity is, the amount of water available in an area. Okay, so high pressure. We know that high pressure is pressing down. Low pressure, we know, is lifting, low lifting. Okay, when we're talking about air, we're talking about the atmosphere. This is the ground, right? So here's some trees. Here's our trees. Maybe we have a house. Okay. This is the ground. So this is how large these pressure systems are. This is moderately to scale, not perfect, but you get the idea. So we have high pressures pressing against the surface. It hits the surface. It moves across the surface. And then it starts to lift back up. And this air will start to cool. Boom. See that? Oh my gosh, it looks like convection. It's because it is. You're so smart. Okay. High pressure sinking, pushing against the earth. Low pressure lifting up off the earth. Now, we're going to take this an even step further. High is dry. Happy, dry weather. No clouds. Lifting, watch this. This is evaporation. Evap. Okay? Evaporation. That evaporation forms clouds. Condensation. That condensation will build and build and build. And over time, eventually, it will start to rain. That is precipitation. So your low pressure system is humid, wet air, moist air, because it helps the water cycle. That evaporation is key for the water cycle. Your water cycle can't take place if you don't have evaporation. This high pressure, it's pushing things back down. Water can't evaporate if there's air pushing that water vapor back down. So in a low pressure system, that low lifting air is going to really help evaporation take place. Then as it cools, guess what? This is water vapor. Vapor is a gas. As that water vapor is lifting, we know in the troposphere the temperature decreases. As that temperature decreases, clouds start to form. Condensation. Cooling water vapor condenses into liquid water, and that's what clouds are. It's tiny droplets of liquid water that's suspended in the air. Now, if enough of those little teeny tiny water droplets will come together and it will build and build and build, that cloud gets so heavy, it has to release some of that water, and that water will fall as precipitation. All right, so we know that low pressure is wet, water cycle. Low water cycle, low water cycle. All right, now we're gonna put all this together now. Uneven solar heating, direct, hot, indirect, cold, and pressure systems. These are our pressure systems, high pressure, low pressure. And we're gonna, look, we've already color coded them and everything. So you guys are gonna be great at this. So I'm gonna start at the equator just because that's my business and I like to. This is L. L for low pressure. Okay. Remember, here's Earth's surface, so this air is sinking down, pushing against Earth's surface. This is gonna be high pressure. And then when we put a low pressure, we're gonna draw like a little cloud around the low. High pressure, high is dry. High is dry. Low, water, high, dry. Maybe some rain. Should we do some rain? Yeah. Some rain. Okay, here we go. Lifting. Low pressure. Okay, low pressure. And then up here, high pressure, H. High is dry. That pressing against Earth's surface, pressing down, pressing down. All right, and then right here, we have high pressure again, which is dry. Pressing down, high is dry, no water vapor moving up to the sky. Ooh, that rhymed. And then right here we have low pressure. Okay, low, wet water. And then again at the South Pole, we have H for high, high is dry. High is dry. All right, so this is uneven heating and pressure systems and how that uneven heating drives these pressure systems, okay? The next step is to correlate these pressure systems with the climates that we see across the globe. So just as a little preview, let's go ahead and just kind of write in what climates we're gonna find. So right here at the equator, it's really hot. It's hot, direct sunlight and uneven solar heating. So it's really hot right here, which means that hot temperature, lots of water. This area in between 0 and 30, this is where you're gonna find your rainforest. Tropical rainforest. This area right here, where you have that 30, it's nice and dry, but it's not cold, right? Because you know the tropics are right here, so it's a little cooler than the tropics. So like, let's say the tropics are like in the summer, like 95 degrees. This is gonna be like 80, 85. This is going to be an area called a desert or chaparral. Chaparrals they're similar to, if you've seen the opening scene to The Lion King, that's a chaparral. So remember, dry, desert, dry, but still hot. Right here at 60s, this is where you find, 60 degrees, we have lifting, low, it's a little bit cooler, so we have our tropical rainforest here. Right here, because we have low lifting, lots of water, we are going to have our conifers, our coniferous forest, and our deciduous forest. This is what we have. These are our pine trees, our oak trees, things like that. Rainforest is your tropical trees. These are going to be the trees that we have in North Carolina. So this is called your conifers, conifers, C-O-N-I-F-E-R-O-U-S, conifers, cones. Pine trees have pine cones, coniferous. Deciduous are the other trees that don't produce cones. They have flowers, like magnolias, dogwoods, oak trees, although I think oaks have acorns. Okay, so these are conifers forest. And then up here at the poles, this is where we have the tundra. Tundra is essentially a sheet of ice. This is considered a desert. It's a frozen desert. Tundra is a frozen desert. All right, now, as we go down into the southern hemisphere, looking down at the 30 degrees right here, this is also where we have more desert and chaparrals. There's some grasslands spread throughout too. Now, the interesting thing about the 60 areas, like 60 to 90, is, so this is also the Arctic tundra. So we have the Arctic and the Antarctic. This is the Antarctic tundra. There's no major land masses. However, in South America, there's a tiny sliver of tropical rainforest. If there were, it wouldn't be, I'm sorry, I misspoke. It wouldn't be tropical, but there's a little bit of deciduous forest in the very southern portion of South America and Africa. But fun fact, the majority of our land masses is actually in the northern hemisphere at the moment, minus Australia, Africa, and even Africa is kind of more, the majority of it is right here with the Sahara Desert. All right, my friends, that is a solid set of sketch notes. That is all we are taking for today. Make sure you have your page number, your title, you're updating your table of contents for me. You may now transition and move on to the set of questions that go along with these notes. Thanks, y'all.